Alright, it looks like we made it to the last video, which is going to be about MOSFET amplifiers, and we're just going to go through one quick example, since the remaining videos of this course only really cover the N-channel MOSFETs. Other FET circuits will be covered in the Advanced Electronics course, and we'll pick up and go through a lot more MOSFET amplifiers. Now, looking to the future, the next course that I'd like to look at is kind of an intro to programming course, something that's kind of basic. So for that, I might look into using something like an Arduino, and the Arduino uses a variant of C++. Now after that, we are pretty much done with all of the introductory EE courses. We had an intro to EE course, we covered that. We had a circuit analysis, we did that. Then we covered logic, then we looked at advanced circuit analysis, and now we are finishing up the electronics course. So it looks like the last thing to cover is the programming basics. I'm still unsure about how I want to go with this math and physics route. But anyways, we can get back to MOSFETs, the real reason you're here watching this video. So let's consider an amplifier. So the amplifier circuit that we're going to look at looks like this, where we know that we're going to have our N-channel MOSFET. We have some capacitors. We have an input voltage, which is AC right here. We have another DC voltage right here, and then we have an output voltage. Now we know from our BJT analysis, we need to do DC and AC analysis, and we're going to go with the assumption that our capacitors are quite large, such that in the AC analysis, we can simplify that by a short circuit. And we start with the DC analysis because typically it allows us to find things that we need for the AC analysis. So let's start with our DC analysis. So if we treat our capacitors as open circuits, as they would in DC analysis, we're left with this circuit here. Now we could do the pseudo source transform thing that I like to do to arrive at this circuit right here, or we could pose a question. So could we treat this circuit as if we simply just wanted to do a voltage divider? It seems like by the math we could, but then we get this resistor right here. We know that no current is going through this parallel combination, so we can say that this voltage right here, that's going to be our Q point voltage, or VGSQ. Now, if we assume saturation, we can find the drain current at the Q point. And to move forward, we really need to know two things, K and our threshold voltage. But in the event that we do know those, we can actually find our transconductance from what we found in the last video, where we have 2 times the square root of K times IDQ. And that's under a square root as well. And we need to find this transconductance because that is one of the values for the AC analysis in the dependent current source. So what we also need to know is the characteristic plot for the MOSFET that we're dealing with. So let's say we found VGSQ. Let's say it's 3.5 volts. And we know what the Q point drain current is, so we could probably find the Q point drain to source voltage. So let's say that it is right here. Now if we wanted to find this resistance RD, well, what do? We take the VGS Q point voltage and we can look at the ratio for the drain current and VDS. So if we're able to find that resistance, well, then because we know the transconductance and that resistance, we can plug that in to do our AC analysis. So if we do that, the circuit that we originally had right here now becomes this circuit right here, and we can start to make some simplifications. So the first thing that we can do is combine lowercase rd, capital RD, and that load resistor. We can call that RL prime. And then we know if we did a KCL around that loop, we could say that the output voltage is equal to this current times RL prime, and we get this negative sign because of how we define the polarity right here. So this allows us to find our output voltage. Now our input voltage right here is simply the voltage divider between the parallel combination of R1 and R2, along with our source resistance. And that is actually what we are going to define as VGS. So now we could define our voltage gain given by A sub V as the output voltage divided by the input voltage. And that is going to be equal to a minus sign multiplied by the transconductance times RL prime. Now again, if we wanted to find the open loop voltage gain, we would just disconnect RL such that RL prime would equal lowercase rd and parallel uppercase RD. But we can also define an input impedance similar to how we did for the BJTs. So we're just going to look into our input terminals, and we know that we have the parallel combination of R1 and R2. And for the output impedance or output resistance, we would disconnect the load. We would look into the terminals where Vout is, and we'd set that source equal to 0. And if we set that source equal to 0 right here, well, then we know that this value right here is also going to be equal to 0. So if this is equal to 0, this acts as an open circuit. And if we look into these terminals on the output with RL disconnected, we really only see the combination of RD, lowercase rd, and uppercase RD. So that's going to be our output impedance or output resistance in this case. And that's what we usually want to find in a circuit. It is some voltage gain, whether it is with a load or without a load, an input impedance and an output impedance. And if we really look at what we've done in this course, we've looked at amplifiers. That's it. I mean, we've looked at diodes too. But in the general scheme of things, or the grand scheme of things, we started with a black box for an amplifier. And now we have developed several ways to make that amplifier. So over the last 20 some odd videos, all we've done is shown how to make an amplifier. And these aren't the only ways. There's a million more ways to do this. But I guess closing thoughts would be that MOSFETs are used everywhere. So just because we only covered MOSFETs in 4 videos and we only covered one kind of MOSFET, that's not everything. I hope you enjoyed this series. If you learned anything new or helpful, please like, comment, share, subscribe. Helps out the video. We'll see you in the next playlist, which again will probably be programming basics or something of that nature. So thank you for watching, and again, we'll see you then.